Hi, today I'll be attempting Codeforces Round 869, Problem D. Haven't read this before, we'll read it right now. And this was the, I had done this contest, but there was no time to read this problem. So that's what I'm going to be doing. And let's go. Okay. You're given a simple undirected graph with n nodes and m edges. Note that the graph is not necessarily connected. Okay. The nodes are labeled 1 to n. Okay. We define a graph to be a fish graph if it contains a simple cycle with a special node u belonging to the cycle. Okay. Apart from the edges in the cycle, the graph should have exactly 2 extra edges, or it should look like a fish. A simple cycle, the special node u should belong to the cycle. Apart cycle. Okay. Determine if the graph contains a subgraph that is a fish graph, and if so, find any such subgraph. Taking subset of edges of the original graph. I see. Edges form one possible fish graph. Okay. Both edges should connect to U, but they should not be connected to any other node of the cycle. Okay. Yeah. Yeah. Test cases, NNM 2000, number of nodes and number of edges. Each of the next M lines contains a description of the test case. No two edges connect the same unordered pair of nodes. The sum of N and M overall do not exceed 2000. Okay, so you can do an n square or m square solution. So first thing is, okay, so you need node with degree greater than or equal to 4. And for 2 of them, two of the nodes should result in a cycle. Yeah. For the constraints they gave, like it seems since we can do n square, let me, oh no. Okay. Mhm. So suppose I take some, okay, let's just think. I take some node, I see it has degree 4, okay, and I start off at this edge, and I'm wondering if it results in a cycle. So I keep going, and I reach an endpoint, right? I either reach an endpoint or I reach back to this node. If I reach an endpoint, yeah, this doesn't result in a cycle, so I stop, and then possibly the next guy results in a cycle. Um, okay, so either I reach an endpoint or I reach something else, like some other node I've seen before reaching the original node. So there is a cycle, but doesn't involve this node, right? So then, yeah, I need to stop. And then this next guy, again, I can check if, and the good thing is, because this wasn't a cycle, I know I will never reach back to any of these nodes because if, oh, one sec. It's not obvious where to go, right? Yeah, it's not a single guy, it's a depth first search from here. So you start at this node and you start whatever connects it. Oh, okay. So you have this node, you have a bunch of guys that connected, another bunch of guys that connected, and so on. Okay, what do? You go here, you're wondering whether from this point, if you will come back to this, right? So you start a DFS here. Okay, hit this and 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 you don't come back. Okay. Um if there was a cycle here, what do? Um you need to start here and you need to create like okay, you're allowed to hit this guy, but you're not allowed to go back on any of these guys, right? Because if you do, you won't reach him. You might get stuck in a cycle, right? So you start a DFS from here. Okay. And then if you hit back, you know there's a cycle and you know that there were 2 extra edges, so you're good. At least 4 edges. And oh, and you need to ensure that these don't hit any other node in the cycle. Okay. So what do? Yeah, I'm very secure in the n square time they gave us. I feel like okay, that's sufficient to do this nonsense for every node, because like because the DFS trees of one of these guys won't hit the DFS tree of the other guy, as long as, yeah, if it did, then you would go back. You would have hit this. So I think that saves us from repeating nodes for a given, like starting at a given node. But a bigger problem which I need to take care of is having like a cycle but having another edge connect like this, right? Now what happens? And having this edge connect like this. Now, is this a fish graph or not? So I guess there is a fish graph here. Oh, and you need to return such a graph as well. So here, for instance, I see that these are my neighbors, neighbor 1, neighbor 2, neighbor 3, neighbor 4. I might start here and I might say, okay, let me start DFSing. I go here and then I pick something to go at next. Say I pick this. If I pick this, I come back here and then there's 2 more. So this is a fish graph. But by chance, if I pick this, this, and come back here, so not a fish graph because these 2 guys touch the thing. So how do I find the right graph? Let's do the example. 3, 7, 8. 1, 2, 2, 3, 3, 4, 4, 1, sorry, 4, 5, 5, 6, 6, 7. Sorry, 4, 5, 4, 6, 4, 2, 6, 7, 6, 7. Yes. Five, 4, 6, 4, 4, 3, 1, 4, 2, 1, 3, 2, 1, 3. This is the one they found. Mm. Mm. Okay, maybe let me say my whatever ideas out loud. So the first idea is, maybe let me read. Yeah, let me do more examples first. Okay. 6, 7, 1, 2, 2, 3, 3, 4, 4, 1, 1, 3, 3, 5. So it's yes, and the graph is 5, 3, 2, 3, 5, 3, 2, 3, 3, 1, 4, 3, 1, 4, 3, 1, 4, 3, 1, 4. Wait, what? How's this? So not even a fish graph today. 6, 7, 1, 2, 2, 3, 3, 4, 1, 2, 2, 3, 3, 4, 4, 1, 1, 3, 3, 5, 1, 3, 3, 5. Okay. 5, 5, 3. Oh, sorry, not this. 5, 3, 2, 3, 1, 3, 4, 3. Okay, this 1, 4. Oh, I see. So this and these two. Okay. Yeah, it's a fish graph. The last one, 1, 3, 3, 4, 4, 1. 1, 3, 3, 4, 4, 1, 1, 2. Yeah, you can't make. Okay. Yeah, ideas. I write an S boldly. But okay, what happens if you just pick a node? So let's assume like we take turns to let each node be the special node. And we pick a node and then we get O of n for each node, okay? So just for a single node, what can I do? And yeah, assuming it's given to me that this is the special, if at all there's a fish graph, this is the special node. What can I do? Okay. If I start doing a depth first search from here, yeah, we've been promised that between the no two edges connect the same unordered pair of nodes. So it'll never be like cycle of length two. It's always a, wait, let me read that again. No two edges connect the same unordered pair of nodes. Yeah. So it'll never be a cycle of length two. So that's a good guarantee. Mm. So what happens if I do a DFS? I start here, I go here. And say I come back. Say at some point I reach this. What can I say about that? I know that there has been a cycle, but I don't know if these two nodes, the other nodes of this, are not neighbors of the cycle. Okay. So there's a cycle. You can't find a cycle, that's great. There's no fish graph with this thing. If you do find a cycle, how do you know it's valid? Okay, maybe first think of whatever is coming to my mind. Okay, so the neighbor, I can have the set of neighbors for the original node, and then I can have each time I hit a point, I know what the cycle is made of. So for each of those points, I have their neighbor lists, and I need to ensure that the neighbor list doesn't, I mean, all of the neighbor lists combined, if okay, if I start with the neighbors of the original node, and each time, if it is a potential neighbor of the one I'm in, if I sort of subtract those neighbors, and eventually I need to be left with at least two neighbors. Okay, how can I do this? Is this like an easy operation? So, when I say I have the original neighbor list, if I hit if I hit a node, or maybe once I know there's a cycle, if I come back and be like, okay, what is the neighbor list? And yeah, but that seems to me like if I take the neighbor lists of all of the nodes in my cycle, that might just be an O of n, which is not allowed for a single cycle of this special node U. Any other way to do this? Hmm. Yeah, if I can figure out the neighbor lists thing, I think I'm done. Oh, maybe it isn't as like space heavy as I thought. Maybe you want to do a breadth first search and okay, happens each of Hmm. Even while doing the DFS, what happens if you come across a node that you already seen? mean that there's a cycle. Because you would, I feel like there were these different types of edges on a DFS or something that we learned. I forget it entirely. But what does it mean if yeah, if you have how can I break this down into something? Oh, I just realized an interesting thing. Suppose um you have this whole shenanigans going and you end up with this cycle, but say this is the neighbor, so this is annoying. So that automatically gives you a new cycle. Okay, yeah, I guess this is what I want to say. Uh, yeah, let's say it's like this, okay. And then you start a DFS here, you go here, say you go here, 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 and you reach back. Awesome. But somehow you found that this guy is a neighbor, and that's annoying. Then but then we know that this means this is the fish graph. Is it true? Okay, then I guess we can ask, is it true that every degree 4 guy with, let me, node with a cycle is part of a fish graph, or is the U in a fish graph? Let's see. So there's a degree 4 guy, and as you imagine, there's a cycle. Now, the way the cycle wouldn't be in the fish graph is if this were a neighbor of the cycle and this were a neighbor of the cycle. But the moment this guy becomes a neighbor of the cycle, you can make this the cycle of the fish graph and have these two out. So what does that mean? But how do I formalize this? So let's say you do find a cycle. It'll be between some two nodes. Okay. And the other two edges, if they are not neighbors of the cycle, that's fine. But the issue is when the other two edges are neighbors of the cycle. So let this be one neighbor of the cycle, and let this be another neighbor of the cycle. Now, if you do have one neighbor of the cycle, now start at any one of the edges of the original cycle and go up to the neighbor and complete it. Then what do we know? We know that this other guy here, is he a neighbor of the cycle? Or maybe it will be more instructive to attempt to construct a fish graph with a cycle, of degree 4, with a cycle, a graph with a node with degree 4 with a cycle, such that it's not a fish graph now. But this is a fish graph node. We don't like that. So this has to be a neighbor of this. This is still fish graph. We don't like that. Oh, okay. Let's see. So suppose you have this and you have this. No, that doesn't. This is a neighbor of the cycle. But I was getting somewhere. If you Oh, maybe I'm thinking about, wait, oh, I think I was thinking about this wrong. Yeah, I was thinking about this wrong. For example, oh no, I think I was thinking about it completely wrong, in fact. For example, this is a fish graph. Oh, this is okay. This can be a neighbor. That's, oh, being a neighbor is not an issue. Both are just, but should not be connected to any other node of the cycle. So this and this should not be connected. I see. Yeah, that sounds easy enough. I just shouldn't have. Then I claim, hmm, you find a cycle. Hmm. You find, yeah, okay. Okay, fine. So you start at U, okay, and whatever. You're doing depth. You're doing a breadth first search, yeah. Okay. All of these points, that's fine. Then you check all of these points. The first time anyone hits you, you're getting back. Now, what does that mean? If the first time anyone hits you, you get back. You say that's your cycle. What that means is these guys can't be in the cycle. Why is that? That's because if you got back, mm, You go here, you ask, what are all your guys? You're not you, not you, not you. So you go here, you stop. Go here, you stop. You go here, what do you? Oh, you found a U. Okay, then you're coming back. Then what can we say about the other edges of U? Can we say they don't belong to this cycle? Let's say if they belonged to this cycle. So if the other edges of U here, so some other edge of U connected this, then by definition, I would take this root back and I wouldn't connect to this other edge. So if there was another edge connecting the new cycle that I made, if there's another edge connecting before this, that means I would have seen it because I'm doing a BFS everywhere and I would have come back here. Therefore, it means that there was no such edge because, yeah, no such edge. So it means that the other edges of U are okay. So they are allowed. So I just need a degree for, I just need to do a, okay, so my final solution is all greater than equal to degree 4 vertices do BFS complete cycle the first time you see U. First time you see U, and any two neighbors plus any two neighbors not equal to first and last. I can just mark first and last. I mean, at most 4 indices I have to find the rest. Yeah, that seems like it's solved after a lot of like unnecessary traversing. Yeah, I'll have to go, but I will code this up soon. Do BFS, complete the cycle. In a DFS, it's somewhat clear how I would store the cycle. In a BFS, it's less clear to me how I might store the cycle. Yeah, I need to think about that. But yeah, that was a good session. See ya.